Hi, we're Northwest Hemp, and today we're going to be talking to you about our investigation of hempcrete that will be taking course over the next few months. My name is Eric Allen, and I am a civil engineering student at Gonzaga University.
My name is Cassidy. I'm a mechanical engineering student.
My name is Anthony. I'm an engineering management student.
My name is Coral, and I am a civil engineering student.
So for our project, we have two sponsor companies, the first being Hemptecture. Their main focus is of having zero impact on the environment with the use of alternative construction materials. They also focus on consulting architects and contractors on their design and build phases of projects. And then they also hold educational workshops for the public to help spread awareness on hempcrete.
And our other sponsor is ZillaWorks, and they're currently in the process of making a prototype epoxy resin from industrial hemp oil. And they just won a huge $100,000 grant from the EPA Small Business Innovation Research Program. And that's just because this prototype is very environmental friendly and sustainable. And yeah, they're supposed to be done with their prototype at the end of the year, which is exciting for them. Okay, so our project is, I'm going to tell you about why we're doing it. So we want to understand hempcrete. Hempcrete, first off, is not a structural material, so that's a big part of what we want to clarify with you guys. This is a map of the United States, obviously, of where in 2016 industrial hemp was legally able to be grown, which is the yellow states. And as you can see, it's not very many states. And so with that being said, it's just an up-and-coming thing in the United States. And so that's why we're taking an interest in it now.
And another big part of this project is to analyze sustainability. Specifically, a lot of research has been done on the environmental side of things. Hempcrete is actually considered a carbon negative or better than zero carbon material, which means that more carbon is removed from the atmosphere during its growth, or hemp's growth, than it is emitted during its use or processing. A study from the UK showed that 165 kilograms of CO2 is sequestered per 1 cubic meter of hand-packed hempcrete, which is pretty cool. And this is because it's a tall, quick-growing plant. It grows up to 15 feet in 4 months.
In terms of economic sustainability, hempcrete is pretty exciting. The hemp plant itself has an extremely high yield. Hemp can grow up to 13 tons of biomass per acre when compared to other cash crops like corn, which you can only grow up to 4 tons per acre. It's very efficient in terms of land use. A recent development for hemp is that in the state of Washington, farmers planted their first batch of hemp seeds, which means in the near future we'll be able to source our hemp locally and reduce transportation costs and emissions.
Alright, just clarification, the difference between hemp and marijuana. They're both in the cannabis family. Marijuana is known for its THC levels and used for medical and recreational use. It's very difficult to grow, has to be grown indoors, it's high maintenance, needs pesticides. Hemp, on the other hand, as Coral mentioned, can grow up to 15 feet tall in 4 months, which is really tall. It's dense, it doesn't need any pesticides, it's naturally resistant to bugs, can grow in multiple climates, and its THC levels are below 0.3%, so there's no psychoactive parts of hemp, the plant itself. And then the next slide. This is a hemp stalk. We're using the hemp hurd from this plant, and that is the main part of our hempcrete. And as you can see, this plant can be used for a ton of different things, again with the sustainability part of hemp itself.
So as Cassidy mentioned, the hemp hurd is the main component in hempcrete, but kind of what it does is it replaces the aggregate, the rock and the sand that you would normally find in concrete. So that makes it a non-structural element, as was mentioned before. Its main use is you kind of fill walls with it to add insulation and moisture transmission that is more favorable to comfortable room temperature and just better storage capabilities. The hemp hurd is, the lime binder is the other main ingredient, and this replaces the cement that you find in concrete. It has very similar properties to cement in that when it gets mixed with water, it goes through a process of hydration and hardens. yet in its processing and manufacturing, it creates much less CO2 emissions than cement does. It's also a little bit weaker, which is why, yet again, not a structural element. The third essential ingredient is water. You just need to have the right ratio of water in order to properly hydrate all of your lime. The other important factor with the water ratio is the curing time. In our research, we found that hempcrete can take anywhere from 15 to almost 80 days to cure because of the natural properties of it being a wood. So if you put too much water, it's going to take longer to cure. So figuring out that ratio is very essential. And then the last thing you can put in your hempcrete is a pozzolan. And pozzolans are things such as fly ash or volcanic ash that you add to concrete in order to manipulate the properties of how it cures. You can increase air ratio, you can decrease density. There's all kinds of pozzolans with different effects. We have pretty much no research we could find on how pozzolans affect hempcrete. So that's one of the things we hope to research is what kind of benefits or cons pozzolans have for hempcrete. The pictures on that last slide, by the way, are of the actual materials we've gotten donated by our sponsors so far. They're down in the lab right now.
That's what you guys are looking at.
Yeah. So we're going to start testing soon. We're going to create our first batch on Monday, actually. And speaking of testing, we're going to be doing 3 different types of tests. Our sponsors requires us to do insulation testing, fire resistance, and water transmission because there's not much research done on this. We're additionally going to do compression and flexure testing just because the environmental and materials testing lab here has that. It is non-structural, but we're just testing to see what data we can get from it. And our sponsors gave us a list of ASTM standards, and we will be going through those and figuring out which ones we'll be using.
Here's a snapshot of our project timeline. One of the things we wanted to do before we got to our practice batches, which we'll be mixing on Monday, is really understanding and researching the material properties of hempcrete. That way we can select the right testing standards to test our batch 1 and batch 2 with. After we do our batches, then we're going to select the final mix design to build a 10-foot by 10-foot shed with, and we will be filling the walls in with hempcrete for long-term testing on its insulation properties.
So this photo here is Highland Hemp House in Bellingham, Washington, and it is one of the sponsors' projects, and it's filled with hempcrete. So this is just an example of what the final product looks like. It's non-structural, it's an insulator. The goal of this project is one, to learn about hempcrete as a material, and then inform organizations with that data that we achieve from the testing. And then lastly, we'll create a 10 by 10 foot structure, which is going to be used as an example for the sponsors, and they'll be doing long-term testing on that. So yeah, thank you. Do you guys have any questions?
Round of applause. All right, take questions first from advisors, DAB members.
This is our team, so. So I know one thing we talked about when we met at the dinner was the smell absorption. Are you guys gonna look into that at all to see if it absorbs smells? Or is that something that's kind of, you decided it's out of the scope?
I think like for our testing purposes, I don't think that's something that we're going to have a capability of doing because we're not going to be building a structure till the end of the year. We'll be more like figuring out which mixes work best for the hempcrete, but I do think that's something that they might do with our 10 by 10 structure for long-term research. One of our sponsors, Hemp Architecture. But yeah, I don't think we'll be touching on that.
So I could probably drive up to Bellingham and smell this house, right?
And Lauren said she went, she said it smelled really, like, it's like really fresh.
Yeah.
Okay.
Yeah, you don't smell any chemicals, it's just, well, they're not really using them, they're using
Right.
like oils to finish it and stuff like that, but it just smelled very fresh. There was no odor,
Okay.
really, it just
Interesting.
smelled really, and they were commenting on the sound insulation, it had very, very good sound insulation too.
My other question was, what you mentioned at the end that you're going to inform organizations of this data. What organizations do you plan on informing, and how are you going to do that?
So our final report will contain all of our data, and we're gonna provide that to our sponsors, and they'll be using that when they're talking to the companies that they're consulting with or working with on projects. And additionally, I think we want to have it conform with some of the Washington, specifically Washington codes, and just, especially with the insulation tests, we wanna make sure that it conforms with the code so that more people will start using it.
So this is my 3rd year doing DAB, and typically this time of year, you know, there's a little bit of roughness. You all seem like you've done your research and your homework, and you all sound like you're excited about this, so very good job. I'm impressed.
Thank you.
Thank you.
Thank you.
So I did want to ask about the north, so you're putting this in between the walls, so we might put plywood up as the structural thing, but then we're filling it in with this hempcrete. So yeah, it seems like it would sound barrier as well as insulation, as well as, you know, kind of any number of things. So you're gonna use this instead of other types of commercial fiberglass insulation, right?
It can, yes, that's correct, but it can actually serve as the whole wall.
Okay.
You have to put up formwork for when it hardens.
Okay.
But you can take that off and it will merely be it'll look like a concrete wall.
Okay.
But it'll be made out of the hempcrete. The building just needs to have structural columns and other types of
Okay.
supports in the wall.
Got it.
But that's what buildings already have.
And then on
Those
top of
colors.
that, they put an oil, like Lauren was mentioning, or a render or some kind of paint. And usually that paint is, water can go through it. I can't remember what the word is, absorption, so that it doesn't trap the water in the wall.
Yeah.
Also, just another fact I remember, hempcrete itself is really cool because it regulates humidity because it doesn't absorb moisture, so it'll hold in the moisture but also release it as soon as the exterior humidity changes, which is really cool. And I've seen just from looking things up where they'll put it on older buildings as a new insulator, and it maintains the proper the old materials of those buildings longer. So it's sustainability for something like that, using it on old buildings is really cool.
What about things so we have over in Seattle, at least on the west side, it's a lot damper, right? I mean, how does this work in places where there's higher percentage of mold and moisture from that in older houses?
That's one of the things that our sponsors are going to want to find out from the long-term research after we fill in the 10x10 shed.
That's gonna be cool.
What year was this built? Is this just being built now?
Just now.
Okay.
Just finished.
It's just
I
finished?
think it's that's a current picture.
Oh, okay.
Might be from their Instagram or their website or something, but they keep posting things about it. They're really excited about this new building.
Questions from the students? Freddie?
Where does pozzolan come
Pozzolans, they come from a variety of sources. The common similarity between them is usually very small particle size and an origin that involved high heat. So two of the most common are fly ash and volcanic ash. Volcanic ash comes from volcanoes, and then fly ash comes from blast furnaces and that kind of production of cement.
Freddie?
from? Do you know the unit weight of hempcrete?
We do not right now. That's one of the things we're going to be researching is how does that vary depending on line binder and possibly different hemp herds, and then if we involve pozzolans.
Okay. And I have one last one. How are you conducting the fireproof and the water tests?
That's actually a good question. That's part of our project is figuring out which testing methods are going to be best. One of the the SCM standard fire testing requires 100 square feet, like a wall, which is kind of not realistic for where we're at with this project. So we're going to try and find other ways to do that, specifically fire testing. And Danielle said that she had some friends or some experience with that. So
We do flammability testing at Bowen to make sure the flame.
You should have blowtorch in a wide open space.
I'm excited about that.
Dawson and Wesley?
I was just kind of curious, what the actual problem that you're addressing is, or is it more like a research?
I would say that it's very research centric, but the overall problem is the lack of sustainability in our current building materials. This is just a statistic I know. The production of cement, like Portland, just your generic cement, it creates around 12,000 pounds of CO2 is emitted for whatever the batch size is, and the equivalent for creating one of the lime binders we're going to use is around 2,000. So there's a massive reduction in emission, and then it's carbon negative in general, and it's mostly just focused on increasing our ability to be a sustainable society.
Okay. One other like comment / question along with that is, as far as like sustainability goes, when you have, at least my thought in it, when you have industrial crops being grown, like industrialized, and you have like also, when it comes to social sustainability, you have like issues created where you push people off their land because you need to use it to grow things, or as far as like environmental sustainability, when you industrialize a crop and you said that it's like, it resists bugs, which sounds amazing, but like, I don't know if that's like really legitimate or.
Yeah, so one of the cool things about hemp is that it hasn't been around on the industrial scale in the United States for very long, so there hasn't been much consolidation in terms of, X amount of companies grow 90% of the hemp. That hasn't happened yet, so really there's a potential for this to be small scale on small farms. So I hope that answers your question.
Also adding to that, because it grows so densely, like you could still like produce a lot on a small part of land. And I know I don't know that much about legislation, but I think it's slightly complicated from what I've talked with our sponsors, like high taxes and like it keeps changing and like it's kind of like a mess. I actually don't know the details of that specifically, but I do know because it's so new that that's definitely going to be something they're going to have to figure out, I think.
Just another thing to add on, in regards to, you said kind of something about local sustainability and like communities. It's actually very beneficial to communities because it's so easy to grow. You can go outside and throw it on the ground and it will grow. So a lot of economies are hoping to get boosted by this because their smaller local farmers will be able to grow this easy to grow, high production crop. Like on the Colville Reservation, they actually have several small hemp farms that are just getting started because they really want to boost the economy there.
Yeah, so I don't know a lot about agriculture, but with all the political and like legal issues with hemp, why would you use hemp instead of say like bamboo or like another plant? Like, is there anything inherent in hemp that makes it beneficial?
Well, hemp itself, in terms of legislation, there's been a lot of development this past year. I'm pretty sure that the Senate passed in addition to the Farm Act that allowed for commercial hemp to be grown, and that's allowed places like Washington to start their hemp crops.
That's a good question, because I know last year's group didn't actually use hops to do a similar thing. They didn't get very far because they had to like basically make their own hops into that where we already have it. So like half their project, if not more of it, was actually just trying to get the hops. But that's a good thing. I didn't even think about that, but it's something for us to look into.
If I could just comment on it, I think part of it has to do with all the uses of the hemp stalk. You saw that picture. We're only using about a third of the hemp stalk. So the outer casing, I know that goes into like oils and resins that ZillaWorks is working with. I'm not sure. Yeah, go to the image. Then that bast fiber, it can be used for the most. That's another one of the internal core parts. So it might be you grow the hemp, split it into 3 parts, and then sell it to various organizations. And that way you can reduce the carbon emissions from all of those, hopefully.
This is just more of a comment to help you answer some of those questions, which is the early colonialist United States grew and used hemp for all kinds of stuff. Ropes, sails, clothing, whatnot. The reason we have legislation that prohibits hemp growth is all economic. That was to protect cotton as a crop, as opposed to that. So we have legalized marijuana here. Why don't we have legalized hemp? Those are good questions, right? To at least figure out what the answers are, so when somebody asks you, well, there's a complicated history. So it's not that it hasn't been around very long, it's that it hasn't been mass produced for these purposes, and that, right, there's still some interesting hurdles to overcome, but you can use it for a variety of different things. And so if we end up with legislation that says we can grow it commercially for this stuff, you can use it hempcrete and all kinds of other stuff as well.
Just one quick interesting fun fact on the subject of history. The use of lime binders that we'll be using can be traced back to around 500 BC in ancient Rome, and the use of hemp can be traced back even further. So they're both very old and useful materials if our ancestors were able to figure out how good they worked back then.
You knew it was coming, right?
No, that's so sweet.
Yeah, no one else wants to say. I noticed the students chimed in after the first presentation. I don't know if there was something to do that. I would like to similarly congratulate you on your presentation. I do have some clarifying questions to ask. So it seems like the sponsors are in a large way driving the direction of the work. Is that fair to say?
Yes.
So I hear in your presentation, yeah, it's not structural, but okay, we're going to do some structural testing. I'm just wondering, if I'm a sponsor and I'm throwing money or materials at a project and you're saying you can do something extra with your time beyond what's being asked, I might have concern there. So it would be helpful for me if you could clarify exactly what the sponsor is asking you to do in your project.
Yeah, so they specifically requested the 3 types of testing: the insulation, the fire resistance, and the water transmission. And then they also asked for the 10 by 10 structure because they want to continue testing on it in the future. But we're adding on the compression testing and flexural testing, as well as we're going to do a fun experiment where we're going to create a cylinder and then put it out during the winter time, and hopefully no one will take it, but we're just going to see if there's any cracking or how much water moisture gets into it, or like what it is, how it's affected by the winter weather in Spokane, because it's pretty harsh here.
Just to answer your question a little bit, I think that the compression and flexure testing, we're first going to do that with our practice batch, which is what we already have those materials for. And if it gives us anything at all, any sort of results where it's like, oh, this does have at least some compressive strength, we'll do it with our final mix designs. But if it has like 1 PSI of compressive strength, we probably won't see the value to do that with our actual mix designs.
Yeah, the real reason I ask is because it seems like in the programming of your work, you're actually starting with the structural pieces, and you've got some big question marks maybe around how you're going to do fire testing, right? The water and the other elements that it seems like they're asking for first. And I'm kind of curious as to why you're programming the way you are. And if I were your client, if I were a sponsor, I might be going, wait a minute. I mean, that's all interesting, but how are you going to do these other elements, which seems like maybe you're still sorting it out. Can you flip to the slide on, you know I'm going to do it, the sustainability one? So you have analyze sustainability right there. How do you intend, what does analyze sustainability mean? How do you intend to analyze sustainability along environmental, economic, and local lines?
I think the best way we're going to explain that is that's going to be the biggest research component of the project. We won't be doing a full LCA, but we will be doing sort of a modified one just to make sure that those carbon negative claims are at least somewhat true. And we're also going to just be looking at how, as it becomes more popularly grown in the United States, that will help with sustainability even further, as we won't have to, I think the herds we have right now are from the Netherlands. So if you take out all that shipping, the carbon negativity increases more. That's more of an environmental aspect. The social and local type processes, those will be very hard for us to analyze. I think we're not trying to necessarily measure them, more apply them in that 10 by 10 structure, because our sponsors will use that structure to promote the product of hempcrete to contractors, possible investors, whoever they want to show this product off to, and hopefully the structure will be good enough that those people will say, yes, this is a good material, it's sustainable, we should use this. And that will help increase the sustainability.
And just to clarify again, this is something the client's asking for, an economic, environmental, local analysis of sustainability impacts.
I don't know if it was that specifically, but
It's not that exact breakdown, but they definitely mention sustainability a lot. And this is the easiest way we could think of to break it down, is into the categories we've learned about.
and I mean, back to the question that Dawson asked, like, why would we do this? It's because it's a sustainable material. Like, why not keep using concrete or something else? It's because of this reason that makes it different than any other building materials, specifically. And I think just bouncing off of that idea is why this is an important part of like the research and why this project is actually being done.
Yeah, and I want to take issue actually with that line of comparison, because it's the folks that have taken sustainable systems and designed them, when you're talking about an LCA or even whatever a modified LCA might be, you compare by functional use. So it's very clear from your presentation, I thought you did a nice job of clarifying right off the bat, like, hey, we're not looking at hempcrete as a structural thread on the slide. It's not a structural material. But in comparing it to concrete and its function, concrete does have structural properties. If you're kind of comparing hempcrete to concrete in terms of its insulation purposes or its fireproofing or water testing, I get that because the functional comparison is right. I would just be careful about making that relative comparison between just concrete and just hempcrete. You know, if you're talking about insulation properties, well, what's to stop you from looking at fiberglass insulation from, you know, other things like that. So be a little careful. The one thing I will say, Eric, specific to your, I loved, because I started by asking, like, what is hemp used for in concrete? And then you guys did a nice little breakdown, and Eric, you said this bit about hemp replaces aggregate, and aggregate's not, it doesn't have actually structural properties to it. Be really careful. I mean, aggregate is used as it helps as a binding agent, but it also does provide some structural quality to concrete.
Yes.
So just be careful about, I like the comparison, swapping in and out, what it would typically be used for, but just be careful about that.
Yes.
Trying to clarify structural. Let me see if I got any more. Anybody else has any? Oh, I've got a good one. Okay, on the local or maybe the social side of things, right? I was thinking of this. So you talked about the cure time. That cure time's quite long.
It's very sporadic
Right.
too.
All right, so that there can have some impact,
Yes.
right? Especially if you're trying to look at using this material, again, for various uses. That may have an impact, economically, but on the kind of social side of things, in terms of rolling the product off the line, if you're delaying things or people aren't getting paid for a while or waiting for a longer cure time than they might otherwise wait, you know, producing a bit of concrete or something like that. I don't know, maybe you have it in there to work with.
I think two ways we're going to kind of address that is, first off, when we're doing our mixes, we're going to very accurately calculate water ratios so that there's no excess moisture, because apparently that is what increases the cure time the most, is if you have extra water in the mix. And then secondly, hopefully our mix design will be able to get an accurate real-world cure time after the shed application. Because when you're doing cylinders and such, that's not an actual wall, like an 8-inch thick wall of hempcrete. It has a much different cure time from a little 6-inch cylinder. So until we apply it to the shed, we won't have an actual measure of what kind of cure times we should expect from this material.
I think the cure times would be really interesting, because you could displace someone from moving into their structure or whatever it is.
Yeah.
Sort of interesting.
Supposedly,
All right.
supposedly you can take the forms off within an hour.
Oh, that's great.
So I don't know exactly what cure time means in this sense. Like, is it ready to, like, it may be a year before the moisture completely stabilizes, right? But it may be structurally, or not, it may be effective as a material within a that day. So we don't really know yet what that is.
Yeah, but it seems like it could have an interesting impact
Yeah.
on
Yeah.
the social side of things and the economic. But we won't detain you any longer. You guys have gotten beyond your allowed period of questioning. We'll offer a round